Assalamu alaikum dear students. In the previous lecture we studied about the classification of acids on the basis of strength, on the basis of molecular composition, on the basis of source and on the basis of concentration. Now what is left is the classification of acids on the basis of basicity. I am repeating. Now what we have to study is the classification of acids on the basis of basicity, or there is a separate topic that we call as basicity of an acid. So we will be discussing that, basicity of an acid. Basicity of an acid, or we say the classification of acids on the basis of basicity. Now, what do we mean by basicity? What actually basicity is? Basicity means the number of replaceable H positive ions present in the acid which it releases when that particular acid is dissolved in water. I am repeating the concept, that is, what do we mean by basicity of an acid? By basicity we mean the number of replaceable H positive ions which an acid possesses, and it releases those H positive ions when that acid is dissolved in water. Basicity, the number of replaceable H positive ions present in the acid which it releases when dissolved in water or in aqueous solution. Fine. By basicity we mean the number of replaceable H positive ions present in the acid which it releases when dissolved in water. Now how do we say this? On the basis of basicity, acids are broadly classified into three categories. Three categories. On the basis of basicity, acids are broadly divided into three categories, that is monobasic acid, second one the dibasic acid, and third one tribasic acid. Now what do we mean by monobasic acid? By mono we mean one, by di we mean two, and by tri we mean three. That is, when the number of replaceable H positive ions present in the acid are 1, those acids are called as monobasic acids, HCl being the best example. HCl being the best example. When HCl is dissolved in water, it releases H positive and Cl negative. That is, one H positive ion is being released when HCl is being dissolved in water. If one H positive is released by an acid, the acid will be called as monobasic acid. The acid will be called as monobasic acid. Another example. This is the exception also. CH3COOH, also called as acetic acid, or sometimes we call it as ethanoic acid. Acetic acid or ethanoic acid. Please do not confuse it with the number of H present in an acid. No, it's not like that. If we see at acetic acid, the number of hydrogens present in the acetic acid are 4. 3 here, 1 here. The number of H present in the acetic acid, hydrogen atoms present in the acetic acid are 4. 3 over here and 1 over here. Total there are 4. But basicity actually means what kind of ions and how many it releases when acid is dissolved in water. Fine, CH3 C double bond OH. It contains 4. Now how many it releases? When it is dissolved in water, it releases only one H positive ion. Only one H positive ion. Please note down this thing. It contains 4. CH3OH, here 3, here 1, 4 total. But it releases only one positive ion. That is how many H positive ions acid releases, not how many it contains atoms. Fine. So basicity actually means how many H positive ions that acid releases when it is dissolved in water. CH3 C double bond OH. It contains 4 hydrogen atoms, but it releases only one H1 positive. So this is an monobasic acid. I am repeating, CH3COH is a monobasic acid, not polybasic acid. Fine. Now moving to second part, that is dibasic acids. What are dibasic acids? Those acids whose basicity is 2. Here I am writing those acids whose basicity is 2. What is my basicity? That is number of H positive ions released by that particular acid in water are 2. Those acids are called as dibasic acids. Example over here, H2SO4, when it is being dissolved in water, H2O, it releases 2H positive and SO4 2 negative ions. Since 2 hydrogen ions are being replaceable, means 2 H2SO4 gives 2 H positive ions when it is being dissolved in water. So this acid is a dibasic acid. Another example of dibasic acid is H2CO3 carbonic acid. Dissolving it in HO2O, it gives us 2H positive plus CO3 2 negative, means 2 hydrogen positive ions are being replaceable. These are replaceable, these are being replaced by water. So if the acid releases 2 hydrogen positive ions in aqueous solution, the acid is called as dibasic acid. Dibasic acid. Fine. Okay, the third one being the tribasic acid. What do we mean by tribasic acid? Tri simply means 3, that is those acids whose basicity is 3. Whose basicity is 3, that is the number of H positive ions released by that particular acid will be 3. Those acids will be called as tribasic acids. That is, if 3 H positive ions are being released by the acid, those acids will be called as tribasic acids. And the example being phosphoric acid H3PO4. When phosphoric acid is dissolved in water, when phosphoric acid, here I am writing, when phosphoric acid is dissolved in water, it releases 3 H positive ions, 3 H positive ions. That is, the number of replaceable H positive ions in the phosphoric acid is 3, hence the acid is tribasic acid. Let us repeat what we had studied. We studied the classification of acids on the basis of basicity, or we call it as basicity of an acid. Now what do we mean by the basicity of an acid? By the basicity of an acid we mean the number of replaceable H positive ions present in the acid which it releases when it is dissolved in water. How many H positive ions a particular acid releases when that acid is dissolved in water is called its basicity. On these bases, acids are of 3 types. First one being monobasic acid, second one being dibasic acid, third one being tribasic acid. Now, monobasic acids, those acids whose basicity is 1, or we say the number of replaceable H positive ions present in the acid is 1, we call those acids as monobasic acids, and the best example being HCl, hydrogen chloride or hydrochloric acid. And the second one, dibasic acid. By dibasic acid, we mean the basicity of an acid is 2. That is, the number of replaceable H positive ions present in the acid are 2. The examples being H2SO4 over here, H2CO3 over here, and a third one, the tribasic acid. Tribasic acids are those where the basicity is 3, that is the number of H positive ions replaced by the acid are 3, and the best example being H3PO4, also called as phosphoric acid. H2CO3, carbonic acid, H2SO4, sulfuric acid. Remember the name, king of chemicals. Fine. So this was all about the classification of acids on the basis of basicity. Now we will study about the physical properties of an acid. The physical properties of the acids. Physical properties of acids. The first being their physical state. That what is the physical state of an acid? How do they exist? Are they solids? Are they liquids? Or are they gases? What we usually say is acids usually exist as solids and liquids at room temperature. Acids usually exist as solids and liquids at room temperature. Fine. Acids are usually present in solid and liquid state at room temperature. Now, which are the acids that exist as solids and what are the acids that exist as liquids? Simple example being H3BO3, also called as boric acid. You might have seen the boric acid. It exists in powder form and we use it in case of eye problems. Boric acid. This is the acid that exists in solid state. I am writing the examples of the acids that exist in solid state. I am repeating what we are studying. Physical properties of acids. The first one being physical state. How do acids exist? Acids are usually present in solid and liquid state at room temperature. Now examples. H3BO3, boric acid, it exists in solid state. Another example is oxalic acid, COOH whole twice. Oxalic acid, it is another acid that exists in solid state. Now what are the acids that exist as liquid state? Simple. HCl, hydrogen chloride or hydrochloric acid, H2SO4. These are the acids that exist as liquids at room temperature. So, physical state, how do acids exist? They exist as solids, they exist as liquids at room temperature. Boric acid, oxalic acid being the example of acids present in solid state. HCl, H2SO4 being the example of acids that exist in liquid state. Now, property number 2, that is taste. We know this thing that acids are the substances that taste sour. So, acids taste sour, or acids are the substances that are sour in nature. But is it possible for us to taste the mineral acids that are very strong, or inorganic acids being HCl, H2SO4? Can we taste them? No, we cannot. Mineral acids like HCl, H2SO4 are very strong. They are very strong and corrosive in nature. And hence should neither be tasted nor be touched. They are very corrosive. They can burn our skin, our clothes, the materials that we put those acids in. They can burn the skin. They can cause holes in the metal containers in which they are kept. So acids are the substances that taste sour, we know those things. But mineral acids like HCl, H2SO4, they are very strong. They should neither be tasted nor they should be touched. So then how do we know acids are sour in taste? We have many examples of fruits and vegetables around us in which acids taste sour. Example, lemons, orange. Fine, they contain the citric acid. The tamarind that contains tartaric acid. In a similar way, apples contain malic acid. So we taste by these. We should not taste mineral acids as they are highly corrosive in nature and they may burn our skin and cause severe burns on our body parts and the clothes we wear. They may torn the clothes. So this was about the taste. Acids are sour in taste. Mineral acids should not be tasted because they are very strong. Now the point number 3, that is the property number 3 of acids. Property number 3 is acids are good electrolytes. I am repeating. Property number 3 being acids are good electrolytes. Now, what is an electrolyte? Electrolytes are the substances that conduct electricity in aqueous or molten state. Electrolytes are the substances that conduct electricity in aqueous or molten state. And here I am stating that acids are good electrolytes. By saying the term electrolyte, I mean the substances that conduct electricity in aqueous or molten state. By saying this statement, we mean the acids are actually the good conductors of electricity in aqueous or in molten state. That is, they conduct electricity in aqueous or molten state. I am repeating the third point. Acids are good electrolytes. Now what are electrolytes? Electrolytes are the substances that conduct electricity in aqueous or molten state. By saying the statement, we mean actually acids are good conductors of electricity in aqueous state as well as in molten state. That means they can conduct electricity. If electricity is passed through them, they may be good conductors. Point number 4. Point number 4 being acids release H positive ions when dissolved in water. We all know this thing. According to Arrhenius, acids are the substances that release H positive ions. This being their property, acids release H positive ions when dissolved in water. When dissolved in water, but these H positive ions exist as H3O positive ions called as hydronium ions, and the simplest oxonium ion is hydronium ion, or we may call it as oxonium ion. I am repeating, acids release H positive ions when dissolved in water, but these H positive ions, here I am stating the example, H positive ions react with the surrounding molecules, water molecules H2O, and form H3O positive. That is, there are no H positive ions floating over the surface of water. We cannot see H positive ions. What do we see? These H positive ions react or combine with the surrounding H2O molecules and form H3O positive ions, also called as hydronium ions or the oxonium ions. In the next lecture, we will be discussing more about the physical properties as well as the chemical properties.